Awesome. So thanks everyone for joining. Intro to Observability and OpenTelemetry. I'm Joe. Been a software engineer here at Intelitech for several years now. Just a little bit about my background specifically with observability and OpenTelemetry was I was on a project towards the end of 2023 where I was assisting with implementing some OpenTelemetry instrumentation for a variety of microservices in a few different languages. And that was really my first time encountering OpenTelemetry. And so that kind of pushed me to dig into a little bit more of OpenTelemetry and the kind of the greater observability ecosystem, some of the ideas around that. So my goal today is just to share a little bit of what I've learned. By no means an expert, but hopefully we can answer some questions today. So speaking of questions, my goal is to answer these 4 questions. What is observability? Why does it matter to world-class organizations? How's observability related to monitoring? Maybe that's a term you're more familiar with. What are the 3 pillars? Observability. Man, I'm really sucky at saying that word out loud. What is the OpenTelemetry project and why would you want to use it? So I've structured my slides and content around that. So if those questions are interesting to you or you already know the answers, that's what we're going to be covering. 6 questions there. Well, 4 bullet points. 4 main questions and some sub questions, I suppose. Reese, were you going to say something? I do have a slide around what is world-class. If you're not currently a world-class organization, which is by definition probably most organizations, if it's sort of a bell curve, hopefully you're trying to learn more and push towards that world-class. I would say still, especially if you're not world-class, you should be here. Yeah, I don't even know what do you define as world class? Is that like the top 1% or the top 10%? I don't know. Okay, so we're gonna hop right into question number 1. What is observability? Why does it matter to world-class organizations? So just taking a slight step back, software systems are complex, as you undoubtedly know. They're built on layers and layers of abstractions, leaky abstractions, all sorts of stuff, like a pile of Jenga blocks that any one block could cause the whole thing to come tumbling down. Especially, I feel like here in 2024 now, not 2023, the layers of complexity just keep getting more layers are added to the top of the Jenga block than maybe 10 or 20 years ago. Now you've got things like containers, Kubernetes, cloud, stuff that's not exactly brand new, but didn't really exist to the degree that it does now 10 or 15 years ago. Software systems are reactive, hopefully, so they're responding to changes automatically, especially if you're taking advantage of, cloud infrastructure. You got things like Kubernetes pods are scaling up and down, or Docker containers are automatically rebuilding and restarting. And then software systems are cross-functional, depending on the software. But once you get to a certain scale, depending on your architecture, you start having maybe different services that are built and run by different teams that need to interact with each other in complex ways, but are maybe being deployed at different frequencies, et cetera. And especially once you start getting into, whether it's a microservice architecture or just maybe you're not like full microservice, somewhere on that spectrum, you've got multiple things that are interacting with each other. You start to get into some scenarios that are almost impossible to test for, especially in unit testing or even integration testing, because even if you've got a staging or pre-prod environment, and we've probably seen this before, prod is kind of its own beast oftentimes, and it's really hard to test for things accurately that will only ever really happen in production. So the goal of observability is, as the name implies, give you better visibility into your systems, your complex systems. So I like to kind of try and structure my thoughts around the why, how, what, the golden circle, if you're familiar. I feel like every presentation ever makes a reference to it. Actually, when I was kind of prepping for this presentation, I think I came across a few slide decks and videos that also use that. But thinking about kind of the why, like why do I care about observability? You know, the goal is really help you identify and solve your problems faster and enable your business to move faster. Because at the end of the day, hopefully, what we all really care about is, you know, not necessarily just the tech by itself, but the tech and how it exists within the business that it's a part of, and how can we help the business move faster? How can we help our users accomplish what they're trying to do better? So that's the why. What does the how look like? Monitoring, which we'll get into. That's the second question. What does monitoring have to do with observability? And then other methods of alerting, debugging, stuff that we're kind of familiar with. And then the actual what, like, and this is more specific to monitoring. We've got logs, metrics, traces, are kind of some of the main things within monitoring. And then there's other things like exception trackers. So if you've used like Sentry is really popular these days, that's kind of a tool that's built all around giving you context into exceptions that happen in your production environment, profiling, some other stuff. So observability, we talked about complex systems. You can't necessarily test for everything that could happen. So what happens when something goes wrong? And observability is really the idea of helping you answer some of those questions. Like what went wrong? Why did it go wrong? Can be super difficult to answer. Maybe if you can even figure out what went wrong, figuring out how it happened or why it happened can be even harder. Why is the system exhibiting the behavior? Is the service doing what users expect? And really, as I've bolded at the bottom, can you answer these questions without making code changes? That's sort of I think a good gut check to determine if the system you're working on is sort of meeting the observability requirement. You know, do you have to go in to figure out what's going on and start making code changes and deploy out to production? Or what the way you've built the system and what you have in place like around it, can you answer those questions without needing to make any code changes? I think that's kind of a good place to start if you're not really sure if the system you have is observable or not. So this kind of gets into DevOps stuff. Reese, this actually reminded me a little bit of our talk. So trademark pending on this, but observability is a way, not plug and play. I came up with that. I think, I don't know, maybe someone else did, but no, it's, yeah, pending. So, so my point there is observability is really not about any one specific tool or any like one specific, I can lift and drop this thing into the system I'm working on and all of a sudden it's completely like observable. It's sort of a way of approaching development, and there's certainly tools that are really important, but so talking about DevOps a little bit here, if you've read the Phoenix project or the sort of the sequel, the DevOps handbook specifically talks about the second way, which is this image here, which is really that top arrow going from ops back to dev. The goal there is to amplify your feedback loops. So what that means is you've developed something, you've pushed it to ops, or maybe you don't even have an ops team at this point. A lot of teams don't anymore. It's sort of the dev team manages it all. But you got your software out running in production. How do you shorten the time it takes to figure out what's happening in production and make the changes you need to on the dev side? Yeah, what are your customers, kind of going back to some of those questions, what are your customers experiencing? How do you know if it's a good or bad experience, and how can you make those changes? And if you don't really have, I guess, that arrow going back from ops to dev, then sort of what we're going to talk about is maybe how you might add that arrow in or make it smaller, faster. So Reese, we're going to talk about your question. If I can click on my slide. What is a world-class organization? So this is sort of what I took from some various resources I found, and then just sort of my own thoughts. A world-class organization can change quickly to meet the business needs. A world-class organization is most likely not deploying once every 6 months or once a month, unless they have really specific environment they're operating in. But for your general, software, a world-class organization is able to adapt to, maybe we've all probably seen this a lot. AI is the hot new thing, and if it takes you a year to be able to deploy your first like AI thing because you want to get in on that, then that maybe that's too late, where the opportunity has already passed to enter the market at an opportune time with your new product or your new feature. World-class organizations focus on providing value to the customer or the user. I feel like it's easy as technical practitioners to kind of get caught up in just the technical things and forget that there's people kind of further down the line that are actually using the software and hopefully paying for the software, and that's really what's important. So how does observability tie into a world-class organization? It enables software organizations to move fast and break less things. So you've probably all heard the term, move fast and break things, which I think was Mark Zuckerberg. Maybe it was someone else, but I believe it was him. But hopefully, and this kind of goes back to the second way, if you have more visibility into your system, you can break things less, and when they do break, you can fix them quicker.
Yeah, I think the expectation that you're not going to break anything, hopefully, at least none of us have that incorrect thinking. But providing ways to figure out what happened and fix things quicker that's the key, right?
Yeah. Yeah, there's this idea of like black box and white box observing, where it's like a black box is, you're like sort of just like on the outside looking in, like, is this thing still working? And that's you kind of have to wait till the system's already in a failing state or a degraded state to be able to figure out if it's, there's issues. Whereas like a white box system, you have, and maybe those are outdated terms, but that's mostly the terms I encountered. White box is, it's probably a first party system, like you own it, you can write the code in it, and you can add telemetry or monitoring where you can detect stuff before it actually happens, and hopefully prevent the failure.
Oh, you have a light shining on the code, right? You can see what's going on. Versus black, you're in the darkness, and nothing happens until somebody throws something out of the box. So
I like that. I haven't thought of it that way. I like
cheers. Yeah, so do you increase the quality of events, reduce signal to noise ratio, false positive, PEBCAC errors.
I don't know what the last acronym is. PEBCAC.
PEBCAC.
I don't know what that is.
Problem exists between chair and keyboard.
Oh, can we circle back to that towards the end?
Sure.
Okay.
I was kind of trying to get it in before you switched to world-class org, but I was too slow. I can wait though.
Okay. Yeah, let's circle back towards the end on that. Yeah, hopefully, maybe I'll be able to answer some of that as we continue on. Yeah, so this is from the DevOps handbook as well, which kind of talks about, I think their subtitle is world-class agile companies or something like that. So this is from the section on monitoring. It says organizations with the highest service levels rebooted 20 times less. And I don't think it necessarily matters too much that it's like they're rebooting their servers less or they're restarting their containers less or what's going on. But basically, they had enough visibility into their systems where they could potentially fix them or alleviate the issues without needing to just sort of like, well, don't know what's going on, I'll just restart the thing and hope that it shakes out. Yeah, is the kind of the second part of the quote talks about. So moving on to question 2, and this is kind of going to be a short section, but it was something that I didn't really grok as I was first like reading about observability and monitoring, because they're kind of in some ways were used interchangeably, but I couldn't figure out quite what the relationship was like. So I've got a neat little metaphor here. But my understanding is really, monitoring is within observability. A lot of people use like a sort of a Venn diagram type thing where, the whole area is observability, and then monitoring is like one circle that exists within it, along with some other stuff. Instead of using a Venn diagram, I thought we'd take a look at the Star Wars galaxy. So, and it kind of adds a little bit onto the Venn diagram metaphor. Kind of over in the main area, you've got like all these systems that are in the known regions, and that's kind of what monitoring is. You're monitoring known stuff that could happen, like CPU usage, request latency, doing like logs and traces and stuff. But then over here on the left, you've kind of got this unknown region, which if you're into Star Wars, you know that sometimes stuff comes out of here and stuff goes in, but it's always like this big deal. It's like, oh, we don't really know how to like navigate through there. And the point being that, unknown is like monitoring will only kind of get you so far in terms of your monitoring known stuff, but these systems are complex and stuff can kind of come out of these unknown regions that you don't even know to be like looking for or monitoring. And depending on how you've designed your systems to make them observable or not will kind of determine how you handle these random things that come out of the unknown region. I don't know, the metaphor breaks down a little bit, but I wanted to like get away from just the normal Venn diagram. Yeah, here's your, well, yeah, I guess that's a different metaphor. Yeah, I guess black box, you've just kind of got this like opaque thing that sometimes stuff comes out of or stuff goes in, and then.
But what happens when you hop into another galaxy, Joseph?
We haven't gotten that far.
All right.
Black light if you're dining on the dark system to be able to see the potential problems.
Yeah.
It's the tools that you're using providing you the visibility.
Yeah, but I'd say monitoring is providing you visibility into like the sort of the stuff that you know about, like the stuff that you've stood up. You're like, okay, I've got like maybe this pod running here, this cluster, this database, or whatever. I want to like track specific, logs or metrics around it. And then I guess for the metaphor, the unknown stuff is like maybe the weird interactions that happen between different components of the system that you can't necessarily like if you've got like two things in the system, you can like, okay, I can monitor this and this and the interactions between them. But if you've got like 100 things, and it's like kind of unrealistic to be able to maybe monitor every type of interaction that could happen between like all the different like dependencies and stuff. I don't know.
Or correlations. Can you correlate the weirdness in the different components of the system?
Yeah. So yeah, not the perfect metaphor, but it's Star Wars. So I've been watching Star Wars Rebels a little bit lately, so it was on my mind. Okay. So if you've read about any, observability stuff, you've likely encountered this idea of the 3 pillars. So we're just going to talk a little bit about, what those are and why they're used so often. I thought I had notes here, but I liked one thing that I read was sort of saying like observability is not just these 3 pillars that are so often used to describe it, but like it's more than just these 3 pillars, but what they really are 3 different like lenses of looking at your what's going on in your system. Like I think the metaphor they used was like the RGB, like you've got like a picture and you can kind of look at like the red and the green and the blue values, and then if you kind of overlap them, maybe you've got the full picture. I liked that metaphor because it's like it's not just these 3 things, but that's like a pretty good place to start. And these 3 things are going to give you a lot of visibility into your system if you're using all of them. And like Phil mentioned, kind of correlating them between each other. So we'll just hop into them. So logs is the first one. Probably all familiar with this already, even if we weren't really like, even if we'd never heard the word observability before, we were probably doing some logging, even if it's just like a print statement here and there. So I won't belabor this one too much because I think we're pretty familiar with it, but you've got a timestamp and some sort of value, whether it's just like a string or you've got some structured JSON or even binaries sometimes used by like SQL servers and some other stuff. So kind of some pros, cons, or benefits and opposite of a benefit, disadvantages. They're easy, they're familiar, everyone knows how to just, slam out a print statement and, hopefully your infrastructure makes those available to you in your production environment. Some disadvantages, depending how much you're logging or how many things you're logging, it can kind of lead to some poor performance, especially if you've got like a synchronous logging where maybe you're logging to a file and then all of a sudden something crazy happens and you're like logging like megabytes or even like gigabytes of logs, and then that starts to like cause issues in your system because it can't write to disk anymore, and then that kind of causes other things to break down. They can also be they can be expensive to store, especially if you're not like discarding them very often. Like I said, like sometimes stuff can happen and all of a sudden you got like a ton of logs, and I think there's a lot. This is something I'm not super knowledgeable about, but there can be like really difficult problems to solve around like searching through logs over like a long period of time. And then kind of one of the other main things is they're system scoped. And I wish I'd replaced the word system there, but basically what I mean is if you've got like, and now I'm reusing the word, so you've got like a single service. I should have wrote service scope. If you've got like a single service that exists within a system, then logs are really just going to give you visibility into that single service. But as you've got events and things causing other things to happen in different services, logs are really just going to give you insight into a single siloed service, but doesn't necessarily give you ability to like follow a chain of events across your whole system.
Except for cases where there's a correlation idea, like Bill was talking, and then you might be able to trace it.
Yes, Reese. Let's skip to traces. Yeah. So traces, I think, are really just kind of built on top of logs in a lot of ways. Perfect. It's like I slid you a $5 bill under the table, except I should have had this 2 of 3 instead of 3 of 3. But we'll go back to metrics in a sec. So yeah, traces, like Reese said, give you a globally unique ID that you can trace through all parts of your system. As you've got like your REST API hits another service, which hits a database, which whatever, you have got this ID that you can go in and track, what are these events that are happening for this one specific like request the user made on the front end that's sort of propagating throughout my system. And those are made up of, spans, which are like the unit of work within a single service. And then I should have included I've got a okay graph here. I made this, which is why it's just okay. But like maybe you've got your web server, calls your foo service, calls your bar service, and then later on you call your frombobulator, and you can kind of like track how long different stuff took and where, like maybe the frombobulator is what's taking like, 6 out of the 7 seconds that the whole request took. So now I can drill into that and maybe go, because I have like a correlation ID that's hopefully linked to my logs, I can go look at the specific logs for the frombobulator instead of just sort of, well, something's taken a long time, but I don't have any way of like seeing which requests and different services are correlated to each other. Yeah. So advantages of traces provide end-to-end observability throughout the system. It can be difficult to add it to all aspects of the system. If certain parts of your system don't necessarily support like the tracing library that you're using, you might have some gaps, which I don't know. I've heard some people are like, it should be all or nothing. Other people are like, well, if it provides some advantage, even if there's holes, it's better than nothing. I feel like intuitively, I would lean towards that side. And then it's easier to sort of like piecemeal your way up to full traceability throughout your system. You can just maybe start in like one part or where it's easy and get the low hanging fruit. And then I haven't really worked a lot with service meshes. Phil, maybe you could provide some insight here, or Reese, our AWS expert. But yeah, I mean, basically service mesh is just going to give you, it's going to handle all the communication between your different services and like some sort of microservice architecture. You've probably got like a sidecar process that's handling all of like the network IO between your different services. And if you're using, some like Azure Service Mesh, it's going to give you a lot of observability just out of the box because they're sort of handling all of the events that are happening between your services. Anything to add there? I'm not super, okay, I haven't really worked with them much, but the last thing, 3 of 3, not 2 of 3, are metrics. So metric is, some sort of numeric representation, whereas logs and traces are, maybe like a string, like this event happened, or like in cases of traces, like these events happen that are related. Metrics are going to, track things like latency, traffic, number of errors, saturation. Something that's really cool, specifically with one of the main metrics, like histogram, is if you, if you structure your this is kind of drilling down a little bit, structure your histogram buckets in a certain way, you can sort of like change the bucket sizes. And then just because math, you can just change the sizes like ad hoc and it still works. I don't actually have a slide on like histograms versus meters and counters, but we can talk about that at the end a little bit. So metrics are good for alerting. It's easy to like, if this number gets too high, then send an alert. Storage doesn't scale with usage. If you've got like your little web server running somewhere and you post something and it winds up on the top of Hacker News, and all of a sudden like you're tracking a couple logs for every request, you might like, you're at the top of Hacker News, you're gonna like blow up, and like you all of a sudden have all these logs that you need to store that maybe you weren't expecting. Whereas with metrics, because you're just tracking a number and you can track it in a way where you don't need to like, for example, like your average request latency, you can aggregate your request latency per request on the like your server, and then just emit that average latency like once a minute or something. So you don't need to like track every individual like event that happened and blow up some storage somewhere. So on the flip side, storage does increase with like cardinality, or like the number of labels you have. So if you've got like, I think a common one is API endpoints, like you've got this API as a label, and then all the different like values for it would be your, your individual endpoints. And as you add more things that you can sort of like look at your data through, like filter it on, that's where your increase in storage is going to come from.
Well, the time scale, right? So how finely grained do you want the time scale to be? That will have a big impact on it as well. If I'm okay with aggregating every 5 minutes, that's going to be a lot less data, obviously, than if I have to do it every 10 seconds or something like that.
Yeah.
And either might be reasonable depending on the scenario you're in. You have high volume, a lot of data, et cetera. You might need to knock it down to seconds, whereas something that's longer running, maybe you don't care. So
yeah, that's a good point. I think a lot of how often you're collecting will depend on your like service level objectives and agreements, like what amount of downtime can I handle without breaking those agreements, and that'll maybe drive how often you're checking. Like if you can handle like a week of downtime a year without like breaking any agreements, then you probably don't need to be checking like every minute. Maybe you can check like every 10 minutes or something. Those are just numbers I'm pulling out, but
yeah, I think the other thing to keep in mind too is that this is, and you'll probably talk about this, that this isn't set it and forget it. This is figure out maybe you've got some golden signals, or you've got some other things that you want to know are happening. You start with those and you figure out, all right, am I getting inundated with data that I'm not using? Get rid of some and maybe add some others that are going to give you better information. So it's evolving. You don't expect that that you're going to not ever change this stuff. whether it's in scale or aggregation or, what is actually being emitted, what do you actually care about? Do you care about where people come from, or that's not a good one for metric, but how many web requests there are. Well, I don't really care how many web requests there are. I care about this sort of web request or these API calls, and not every API call, right?
Yeah.
So.
Yeah, the golden signals. So that link, which I'll share the slides in the Teams chat, is from well, I don't know who created them, but where I've mostly read about them is the Google SRE handbook, which is online public, and that's where that link goes.
Do they break them down into different types beyond or below golden, or is it just kind of say these are the golden ones because these are the most important? Or do they say like sub or sub and do silver or anything like that?
Oh, as far as like that specific resource, I think they just have the golden one that's sort of like, hey, if you're going to track something, like start with these, or at least track these. They don't have like different tiers of them, though. I definitely don't think these 4 are all encompassing, but actually let me open it if the link would work. It won't work. Golden signals. This is not what I want. Here we go.
Like it says, I think Google also recommends Torah metrics.
Let's see. I read about that, but I don't remember what it stands for. I think there's like varying, like there's a few different acronyms around like what metrics to like collect, but it's not something I know too much about, so I don't know it like offhand. If you can only measure 4 of these, focus on these 4. I don't know if they give examples of other ones. Yeah, all the links to the resources I use to build this slide will be available. Okay, let's cruise. So we covered traces. We looked at. Okay, we're at 36, and we haven't gotten into OpenTelemetry. So let's hop into some OpenTelemetry stuff, which maybe for a lot of the people online is what they really were interested in if they're already familiar with other observability stuff. So OpenTelemetry, often shorthanded to OTel, is a project that was a combination of 2 previous projects, OpenTracing and OpenCensus. One, I believe, was made by Google. I forget who did the other one, but basically they had these 2 different like observability projects that were sort of running parallel to each other. And the idea was, well, instead of having these 2 competing things, let's bring them together and sort of have one way of doing it. So I'd say this is actually a really good example of, we've probably all seen that, was it XKCD, where it's like, there's 15 projects. I'm going to make one to rule them all. Now there's 16 projects. That didn't really happen here. I think they worked really well together, actually, to like OpenTelemetry is really, it's pretty new. I think 2019 is when it started, or when those projects came together. And they're both, the 2 on the left are now archived, and OpenTelemetry is really the way forward for anyone who is using those projects. And I think it's rapidly becoming like more of an industry standard. So that was like, I mean, it's backed by like, I don't know, most if not all of some of your FANG companies, like the Googles and Facebooks of the world. So that doesn't really tell you what it is. It's open source, which is awesome. Cloud Native Computing Foundations, or CNCF project. I don't actually know too much about like what that means, other than it's an organization that kind of manages these various open source projects. And there's 3 levels where you've got, I forget what the first one is, but like sort of like a new project that's still kind of ramping up. Incubating is like, hey, this thing's pretty stable, pretty mature. We'd recommend using it in production. And then there's graduated, which I think is like something like Kubernetes is a CNCF project. And it's like, this thing is, yeah, it's not like not being worked on anymore, but it's been around, it's stable enough. I don't know too much about how they like determine what state a project is in. So really awesome benefits of it are vendor agnostic and tool agnostic. So whether you're using like AWS or Azure on-premise stuff, if you're using OpenTelemetry, it's going to allow you to not be like locked into a specific tool or vendor. You can kind of move between them. But what it actually is, I should have put that up first, is really comes down to three things that are all sort of like under this umbrella of OpenTelemetry. You've got language-specific APIs and SDKs. So I think there's like 14 or 15 languages. Basically, almost any language you're probably using, you're going to have a software development kit and an API to go in using that language and write your telemetry code. And oftentimes you'll even have an automatic instrumentation library for especially popular frameworks like ASP.NET. You're going to just, maybe add your NuGet package and get a bunch of metrics out of the box without even having to go in and like, add a middleware or add code to every endpoint. So the second piece is collectors, which I'll get into a little bit in a second, which are basically you send your data from your service, your metric data. The collector takes it, transforms it, and then exports it to somewhere else. So I think the way they designed it is actually pretty cool, where, and I'll talk about this on the collector side, you've got sort of like three aspects to your collector, like I'll skip forward, why not? Your receiver, which like all three of these are like basically loosely coupled, where you can sort of like change out all of these three pieces that make up a collector to use whatever service or tool you're using or whatever language you're using. So you can receive data from like all these different languages, typically in either like a RPC or HTTP. And then you can do all sorts of processing, whether that's removing sensitive data or, doing sampling where like you don't want to send all of your metrics, you only want like, 5% of them or something like that. Or you want to transform it. It's kind of like an ETL pipeline in some ways, which is something Clayton's probably more familiar with. And then exporters you can send to, whether that's Prometheus or maybe you send straight to Azure Insights, Application Insights, or whatever, various tool you're using. There's like going to be a different exporter for all of those different tools. So it's cool. You can kind of like, whatever system you have set up, you can go in and pick, the receivers you need, the processors you want, and exporters, and it's just going to work. You also don't have to use an exporter, which if I back up a little bit, so you can see here, you've got the application, maybe you're like .NET service or Django service or something. And then you're using the instrumentation library, which adheres to the OpenTelemetry like API or the spec. And then it sends data to the exporter, and the exporter is going to use the SDK. This is kind of like how the different pieces of OpenTelemetry are arranged, not so much how it's actually sending the data. And then the last piece is the OpenTelemetry protocol, which is just like a open source protocol that's defined for like all these different languages, and all these different like things that are sending data back and forth can use this protocol, and it's it's going to be the same data however you're sending it. I've got another slide that I want to show. Oh,
is that something you have to like stand up yourself, or you talk about these other third parties, like when I see Prometheus and Grafana, those are probably already implementations of collectors, maybe?
So yeah, so that's a good question. So here you've got like your your app service, whatever language or framework you're using, doesn't really matter. And then you're going to send your metrics to your OpenTelemetry collector, which will be, in this case, you have the Prometheus exporter set up to send your data to Prometheus, whether that's like the cloud product you're using, or you have like on-prem Prometheus instance. And Prometheus is going to be like your, like it says here, your time series database, your monitoring system. Grafana is going to take the data from Prometheus and like query it to set up like dashboards and alerting around your data. You could also like replace these two with like Azure Application Insights, and you change out your OpenTelemetry collector, like the exporter config, and then instead it would send to Application Insights if you're not using something like Prometheus, and you can just go in there and like set up your alerting. Does that, and I feel like I didn't answer your question.
For an example of a collector would be the App Insights package that you can add to your .NET applications, right? So that'd be an example of a collector. Now, again, it's a little bit weird because App Insights was invented before OpenTelemetry collector, that this whole terminology was collected, but for all practical purposes, that's what it is. And App Insights, again, in the last couple of years, Monitor supports input from OpenTelemetry. So Azure Monitor will take, if you have a collector that's not App Insights, it's something else, and it supports OpenTelemetry, Azure Monitor can suck that in like Prometheus, right? So they want to make sure that they're competing with these other Azure. Microsoft is wanting to make sure they're competing with these other open telemetry consumers like Prometheus. And then on the production side, again, you can add, that Microsoft has a package. They've already got the collector stuff built in, and they're doing a lot of that. They're receiving signals. It's just from your local application, doing the aggregation, and then emitting the open telemetry out the back end. But that's the concept of it, right? So I can take whatever's out of the box, or I can configure it so that I change my timing, or I do longer term aggregations, or whatever it is to minimize the amount of data that goes out or increase the amount of data that goes out, and then you can override it. You can write some write custom stuff too. All supported. So, and then again, there are agents as well. That you can install. I would assume that there's compatible agents, but on the, specifically on the Azure Monitor side, if you just have a VM that is running some application, you can install an agent and have it emit to, as long as it can phone home, it can, send data out to whatever, Azure Monitor or anything else that supports OpenTelemetry now that Microsoft supports it. But that's one example, right? The idea here is that you're not tied into Microsoft or App Insights. This is a good thing to do across, from a Kubernetes cluster or whatever. You don't have to install App Insights there. You can install, OpenTelemetry collector, agent, operator, whatever.
Like a sidecar process.
Yeah, I think they're calling them operators, but it's effectively a service that you install into your container that will emit, and then report on whatever. In that case, it's reporting on the health of the cluster probably by default. And then
you don't even actually, there's a few ways you can set up the collector, and you can go no collector, where you could so you could cut out this middleman and go straight from app service to Prometheus. I think it's a very much not recommended way to set it up, because then you've sort of tightly coupled these two things to each other, whereas the collector gives you a more of a loose coupling, like an ability to sort of change out whatever this thing is, or change out whatever this thing is. And you can also set these up where you maybe have one per service, or you can just have one or a few that multiple services are going to. So there's a few different ways you can set up the collector.
So how did you configure this in the project we were working on end of last year?
Let's see, how was it configured? It was Kubernetes, so it was a collector per cluster.
Per cluster.
Yeah.
So then all of the services, the application services that ran in that cluster knew how to talk to the common service that was provided by that cluster. And there was some API, was that a custom API that this customer had? We defined this API. You want to send metrics, you send them to this service and we'll collect them for you and do whatever we do with them.
Yeah,
You don't
there's
have to worry about all the plumbing beyond just
right.
emitting whatever it is I want to report on or log or report a metric on.
Yeah, they had like basically a thin wrapper around like the OpenTelemetry and OTLP protocol where most of the services were in one of two languages. So it was sort of just drop in this package and either get essentially automatic instrumentation where you just add this package as a dependency and don't have to do anything else. Or sometimes go in and sort of add a custom middleware to use that package. But either way, it was for each service, it was pretty simple to just drop in this thing and with minimal configuration, start getting telemetry. And they had, so they had this set up, they had Prometheus and Grafana and some other components like Cortex, which is, I think like a extension to Prometheus that I forget exactly what it does. It was all new to me at the time, but I think Cortex helps Prometheus scale, if I recall. I wish Josh Ward was on the call because he works at Grafana now, so he'd probably know pretty well.
Now you tell us, Austin. Thanks.
What did he post? Oh, yeah. Yeah. Okay, I kind of skipped around a little bit. Let me just make sure. Yeah, I basically covered this automatic instrumentation. So most, well-known languages and or frameworks are going to have some level of automatic instrumentation where you just sort of drop in this package. Like for Python or Django, it's just going to inject some like bytecode for you that's going to, wrap around. Like in Django, it's going to wrap around your request response cycle. It's sort of like a middleware. And start reporting this for you. You can also go, like a manual route, or like your own sort of automatic instrumentation if you like build your own package, which was essentially what they had done on that project. And you can customize what information you want to capture. The downside being it's just more work you have to do yourself. It seems like automatic is a great way to get started. And then as you figure out what your needs are, kind of like Phil was talking about, like this is sort of an ongoing thing you want to monitor and adjust for, maybe transitioning to more of a manual approach. So why OpenTelemetry? And we've talked on this a little bit. It's vendor agnostic. You're not locked into whatever cloud platform proprietary solution that is probably just a wrapper around some open source solution. Maybe it's supported in pretty much, I don't want to say all, but I don't think very many languages that like people are typically using that it's not going to already have support for. You can get started really quickly, especially with the automatic instrumentation. You oftentimes can just drop in a package and you're off to the races. So cloud platforms not only support it, but at least in Azure's case, it's pretty much the way forward, like Phil was saying. So these are just some quotes I took from some Azure docs, which, Microsoft Azure docs aren't always like 100% reliable, but Microsoft's embracing OpenTelemetry as the future of their telemetry instrumentation. They have a bunch of documents around, okay, this is what we called stuff in Application Insights or Azure Monitor, and here's what it's called in OpenTelemetry. And so here's sort of the translation between the two. The second quote was from a .NET specific article, just talking about, refactoring Azure's observability platform to be based on OpenTelemetry. So at least for Azure, it does seem like OpenTelemetry is the way forward. Like if you are adding in telemetry to something that's like greenfield development, probably a good idea to use the OpenTelemetry way of doing things versus like other ways of doing things, because it seems like where they're headed. Sort of some conjecture there, but based on like what I've read on their docs, I think it's fairly accurate. Other cloud platforms, and Reese, maybe you can, if you know anything on the AWS side, did less research on this for the other ones because we don't do as much with them, but they both support it, GCP and AWS. The GCP one is, so this is specifically for tracing. I read some documentation that was talking around sort of some non-tracing stuff, and it was more like, here's how you could do it, like if you're using Kubernetes, but I didn't see a lot around GCP, but I also don't use it a lot, so maybe I just wasn't looking in the right spot. I think theirs is more sort of like, we support it, but you kind of are managing it yourself versus like a managed solution. And then I think the AWS one was like kind of a fully managed, hey, just send your stuff to us and we'll handle it. We've got 5 minutes left. So in closing, I liked this quote from, again, that Google SRE book. Sheer force of effort can help help a rickety system achieve high availability, but this path is short-lived and fraught with burnout. Taking a controlled short-term decrease in availability is often painful, but a strategic trade for the long-run stability of the system. And this was talking about something more specific, but I liked it as sort of a way to close out. I really liked the, show of hands, don't have to raise your hand if you've worked on a system that was fraught with, pulling small nighters or, getting constant Slack messages about stuff's breaking or, whatever that is. Like, systems like that can run through sheer power of will and like, oh, you were such a hero. But ideally, no one has to be a hero. You just have visibility into your system where you can figure out what's going on and, over time, prevent stuff from happening. Like Phil mentioned, you're never going to prevent everything by any means, but yeah. Demo if time permits. I don't think time does permit, but I'll share a link. I have I can show it for a few minutes if there's no questions, but I do want to leave a few times for questions. I've got a bunch of resources. Again, this is most of the stuff that I was reading around, kind of preparing for this. There's obviously other great resources, but these are some of the ones I found the most helpful. And with that, I'd just like to, give a few minutes for questions. I know, Kelly, you had a question. I forget what it was, but I promised I'd circle back to it.
You sort of talked about it, about just increasing the quality of alerts to, not have so many false positives, stuff that, increase the signal to noise ratio.
Yeah, I mean, one thing that I liked, and I think this was from the SRE handbook, was alerts should be two things before you fire an alert. One, it should require like intelligence, human intelligence. Like if you're firing an alert that doesn't require a person to like do some critical thinking around it, then like why haven't you automated the solution to it? Like if it's just this, oh, this thing happened, do X, Y, Z, we'll automate that so you're not getting as many like alerts. And then the other thing I think was just like, yeah, making sure that they are actionable. If you're just firing an alert like, hey, this happened, well, what do I do? Like, do I need to do anything? If the answer is no, then, maybe like, why are you firing that alert? Yeah, they had some really good stuff around alerts specifically.
And the signal to noise ratio is always a tough one. And I think the tools have been evolving to help with that. If you have your hand up, I would just go off mute and, I can't tell who has their hand up. View all has their hand up. I don't think that's actually a person. But just come off mute and ask your question or drop it in the chat. But ultimately the point is, and again, I think Andrew has a great example in one of the systems that he built. And this is, again, is an Azure Monitor, but it applies the same where, we were getting faults from the client, but a lot of them we're getting exceptions, but his alert before he's going to go fire off alert, he's querying faults that come up. So just any fault isn't going to trigger it because, hey, we have Google Analytics in our client. Google Analytics will throw failures, right? So if it comes from Google Analytics, we don't care. We're just going to skip it, right? So we still get the signal, but we filter some of the noise. And there's a couple of other examples, and so on and so forth, necking it down so that, all right, if we get this alert, it actually means something to us. It either we want to do something about it. No, there was only A. We want to do something about it. There's no B. It's just A. We want to do something about it. So send it. Yes, go ahead and send us this alert. And if that proves not to be the case, all right, can I go adjust the query to filter out what is clearly more noise? Because I'm not going to do anything with whatever that alert is.
Alert fatigue is real. I think they missed
Yeah.
way too many alerts and people start ignoring.
Yeah, and then pretty soon you've got all these high priority things that you're just totally ignoring because there's so many of them, you don't know which one to rely on.
There was a case study in the SRE book about when Google early on in Gmail's life had a issue and they had all these alerts set up, and it was like this big failure happened and they were just getting spammed with alerts basically. So they just were like, you know what, we're turning off emails from our alerts for a period of time so we can just sit down and actually fix stuff. I don't know that turning off alerts is typically the recommended way, but it was just sort of like at that point it's all noise, and they were like you're saying, John and Reese and Phil, there's no ability to find the signal because there's so much noise. Yeah, it's cool that they have.
Did you jump back?
Go ahead.
Could you jump back to your why slide? Why hotel? I feel like somebody asked a question related, and I don't know that it came up, but it's kind of implied, but it's not really explicit here. But the thing that I think observability practitioners, if I throw that term around, should be really excited about with OpenTelemetry is if you decide you're going to deploy an app and you want to send all of your metrics and traces and logs to Azure today, but then that feels like you don't get the features or functionality or the visibility, it doesn't graph the way you want it, and you want to replace that with Splunk, or you want to move it to Sentry, or you want to replace it with Datadog or Grafana or whatever, OpenTelemetry makes that possible. And the other thing that used to be really difficult once upon a time, if you had a system that was running on Solaris or Linux or some other flavor, and you had another part of your environment that was running on Windows, you had to run different BMC and SCOM and other kinds of monitoring systems dedicated to those source systems. With OpenTelemetry, you've got cross-platform, like you said, whether it's on-prem, hybrid, private cloud, public cloud, those things can all go together to one system, whether that target is Grafana or Datadog or Azure or something that AWS or GCP may or may not support to varying degrees. So I think that's the thing to me that's really exciting about it.
Yeah, for sure. I think that is excellent points.
Yeah.
On both fronts, because again, we've been there with older systems. You get Java, a couple of Java servers, and then a commercial off the shelf, and they interact in some way, and trying to pull all that data together. That was a big freaking engineering project just on its own. Which usually turned into, all right, this is too much trouble, we're not going to do it, and we're just going to hope that the stuff works, which I suppose, but not an ideal plan. Whereas today, and it puts the vendors are putting a lot of pressure on each other too with this openness, right? They've got to be able to compete feature for feature, so you're not making the decision. You have it's easier to switch from point A to point B. So that's a great place as consumers of the tech to be.
Thank you, Brian. Yeah, I agree with that.
Yeah, it's awesome.
Well, we're at 102. Feel free to hang out in the Teams chat if there's more questions. I'll be here for a little bit longer. That's, thanks everyone in attendance and for questions and comments. Again, Brian, thank you for that input. That was great. Thank you, Phil, and everyone else in the room for providing some insights of your own. I dropped both the links in the Teams chat to both the repo for the slides, which are actually all I have open right here is just a link. So you can actually just go view the slides in your browser. And then the link to the repo where I had a real simple Python example that had sending to a local Docker container collector, and then also Azure monitor. So
Awesome.
Yeah.
Thanks much.
Thanks.
How often, or like, what's a good cadence to review and adjust your metrics? Or do you just do it as you're like, I'm annoyed by this alert or whatever else, so I'm gonna do something about it now?
Hopefully it's that.
Yeah,
But I think what happens is I'm annoyed by this, I'm going to ignore it.
right.
But hopefully it's that.
Yeah, I think that's the big challenge I've seen just in places I've worked where it's, okay, we've set up all this monitoring, we've set up some alerts, and now you get either the alert, you can just turn it off or you ignore it entirely. I guess, how do you develop, or is there any tips for developing a culture where you fix the problem or identify that as an issue that you can bring up as a team and solve versus just, well, let's not do any alerting and let's just ignore all our alerts? Like, what's the sweet spot?
I think I have two thoughts. I mean, and also to follow up on the annoying bit, it's when the system crashes or customers start complaining, and you get serious about alerting. That's the other point. But I think getting it in early, and then adding items to your backlog, even if you're not going to touch them right away, it's like, hey man, this the 50 alerts I'm getting every day because some service went down that isn't really going down. I don't have time to deal with it today, but at least let's get it on the backlog. So it becomes an exercise of when does it become important enough, or when do you include it in the planning? I think that's probably, again, reality is this, we know this is going to happen, right? We're going to end up with alerts that we just don't care about. And then there's always something else that's probably rightly more important, but just keeping visibility to it will hopefully, it'll present itself when it is, when it's time, when you're ready to actually tackle it more seriously. Again, I like seeing the stuff early, like a lot of these things, because they can help you early, if you get it in during dev and test cycles and et cetera. But, it is not, it's easier now than it's ever been, but it's still, finding stuff that's useful can be work. Yeah.
Something that's really cool about the open telemetry, like APIs, is like, say you want to go add it into, whatever C# project you're working on. Like by default, it ships with essentially a no-op implementation for like all of the backend stuff. So you can like add it in and kind of set it all up, and it can just be running and not actually like reporting to anything, indefinitely. So you can like get the code in there, and then, as you're maybe figuring out what that infrastructure actually looks like, you can, do that later if you want to, but just start with, especially like if you're using like a template or something that had open telemetry stuff built in, or that automatic instrumentation component, it's like really easy to just add those in really whenever you want, and there's nothing that's gonna
off by default, and then turn it on in code or turning it on in config rather than having to turn it on in code. Yeah, we've taken similar, I mean, with logging as well, right? I mean, you different levels of verbosity in your log, right? Do I want verbose? Do I want warnings? Do I want traces? Or, whatever it is, and being able to tweak and tune that. It's always a good thing to do too, like get logging in. But again, if you've got, get logging in early is always sort of a rule, but at this point, OpenTelemetry is handling that logging too, right? So you're not going to have another third-party logging library that you might put in there to do logging in addition.
Yeah, I think the logging, I want to say the logging or the tracing was one of the, like the metrics logging and tracing. Either the logging or tracing was the most recent one that they sort of finished up. I think they started with the metrics.
Yeah, I think logging and metrics, logging is probably the easiest. Metrics would be second, tougher, and then the tracing is difficult because of correlation. That's a challenge, right? So
I could ask on that too, sorry, with the logging or telemetry, adding that, replace the logging and other stuff that you are doing to get this data into insights or somewhere. Is telemetry kind of replacing that? Or you just can add telemetry to your thing and it's going to get the logs, it's going to get metrics, and it's going to get other data?
That certainly is the promise, right? It supports logging, so you don't have to worry about nlog or, pick the 3, 4 different logging libraries that we've used in the past. You know, and again, the key point there is you've got system level logging, which is what this is typically focused on, right? Your app started, we got a request, you know, those sorts of things versus, you know, typically when we're talking about nlog or Serilog or any of those sorts of things, we're talking about application specific logging, right? So yeah, I received an order. Or I started an order, or I opened a shopping cart, or whatever, you know, whatever those specific application specific logging events are. But again, with the API, the expectation would be, well, I can write my. Again, we've done this with App Insights. Again, I only keep saying App Insights is because, you know, in the .NET land, that's effectively what this is, but it's obviously it's been .NET specific. You know, you could write custom log messages. I don't know how common that has been, you know, at least in the last few years, that we actually write custom App Insights messages. You know, it's not common versus, let's say, logging messages that are application specific. You know, that's also tricky too, because there's you know, like application audit logs, you know, things that are application events, let's say, you know, event logging that this particular thing happened. And you know, it's a business event. I want to make sure it goes into an event log that I might process later, or, you know, use to generate business information. You know, thinking of like the ticketing system that we did, right? We made a purchase, tickets were sold. All right, well, that tends to be really interesting data if I want to look at how many tickets do I sell by day, how many tickets, you know, are sold for this particular event, and so on and so forth.
To mention it too, I think that's helped is just the whole DevOps concept itself, is because now developers are getting more exposure to what's happening in production, and then they have to support it. So they naturally want to write better logging and implementation so that they don't have to stay up in the middle of the night and get called on Saturday. Or
reduce the frequency of calls, the midnight calls.
Right.
Or interruption to your workflow. That's another nasty. Even during the day, you know, 9 to 5. Oh, geez, I got to go handle this event instead of finishing my story.
Right.